Alright, so we're going to talk about a couple special rules that we can use with polynomials, in particular when we multiply them. So we're finding the product here. I'm taking you back to this because it connects to what we're going to do with the polynomials. So if you find the product of this, go back to maybe 5th or 6th grade when you first probably had your exposure to exponents. You were probably taught to just do 10 times 10, to rewrite it. And that would obviously equal 100. The students would put 20 for an answer, or they might be just unfamiliar with what this means. If they could think it means 102, but we're familiar with it. Another review here, 27 times 35. The wrong answer here would be to say, okay, I'm going to multiply 20 by 30 because this is 20 plus 7. 30 plus 5 is 35. Why can't we just do 20 times 30, call it 600, and then do 7 times 5, call it 35, and say I'm done for the day, right? Well, the issue, first of all, I'll show you the standard algorithm. So the standard algorithm has you getting 945, and you can see I did actually multiply the 20 times 30 at one point. That's where I got this 7 from. I'd carried a 1, so 2 times 3 was 6, plus a 1 was 7. And I also multiplied 7 by 5 right at the beginning and got 35. But in between those two moves, I also multiplied 7 by 3, which never showed up over here, and I also multiplied the 20, or the 2 as you see it, but it's a placeholder, 20 times 5. So what we're looking at here, if you were to really analyze this, what we're looking at here is 27 times 35. Yes, we can break it down and say 20 plus 7 times 30 plus 5, but in reality, we don't just do these two steps, which you got before to get 635, but you also do the 20 times 5 to get 100, and the 7 times 30 to get 210. And if I add up all of these things, 600, 700, 910, 945, I get that same answer that we just got with the standard algorithm. And this is kind of a cool way to do the math. You could almost do it easier mentally doing it like this. And where am I heading with this? We're heading toward polynomials. You can see here I've got, this would be a binomial, right? 20 plus 7. And then this would be another binomial. And we're multiplying those together. So let's say, for instance, we had an issue like this. Students, I am telling you, the world over, high school teachers will tell you as well, they're going to want to put this for the answer. X squared plus 64. You're wrong. That's not it. There's more to it. So if we write this out, x plus 8 times x plus 8. This is why I had you look at 10 squared at the very beginning. This is what exponents mean. It means multiply this as a factor twice. Well, here it is as a factor twice. And like we just saw, you don't want to just do the 7 times 30 and 20 times 5, call it a day. You want to do 7 times 30 and 7 times 5. That's what I did down here. 7 times 30 is right there. 7 times 5 is right there. You want to do 20 times 30 right there and 20 times 5 right there. I'm going to multiply x by everything. I'm going to get x times x right there. It's like I'm distributing is x squared. X times 8 right there is 8x. Let me use a different color for the next part here so you can just see it a little clearer. 8 times x is again 8x, so I'll put that a second time. And then 8 times 8, of course, is 64. So yeah, we do end up with x squared and 64 in our answer, but a key part we're missing are these 8x's, which, by the way, I can combine those like terms, call it 8x and 8x is 16x, right? And now we're good. So you can see if I multiply that binomial by the other binomial, I ended up with the trinomial once I took these two 8x's and called them one term. Similar problem, b minus 3 squared. See if you can pause the video and do it on your own now that you've seen me do it once. So we start out with b minus 3 times b minus 3. The b's, they will become b squared. That's a b times a negative 3, so I'd write negative 3b. I do the same thing right here. That's a negative 3 times a b, so I write negative 3b. And then negative 3 times negative 3 is 9. So the popular wrong answer is to write b squared plus 9, but if you did that, you'd skip out on these negative 3b's. And if we're going to combine like terms here, we would say b squared minus 6b plus 9. You get a little trinomial right there. So it's a special case. Again, press pause, see if you can do this one. Hopefully you're catching on. I would rewrite it. Hopefully you're recognizing a pattern that, that first term is just going to be something times itself, right? Those two first terms, and then those two last terms are multiplying by themselves. And then these middle terms, it looks like they combine those 12s to get 24g. So if you had a very generic problem like this right here, we would say, okay, a plus b times a plus b, and then you get your a squared and your b squared on the ends. But this middle part is the part that people miss, which, by the way, you can combine that. Those are like terms and call it that. A minus b squared, it's the same thing, just with a minus sign. These are plus signs right here, and you can't see it here for the positive, but that's because of the fact that you are, on the last part here, multiplying a negative times a negative, and for the a's, multiplying a positive by a positive. Before I get to the product right here, I just want to tell you my favorite teddy bear growing up was Jojo. He was a bear. He had a North Andover sweatshirt, which is where I'm from. I was 4 years old when I got him. I got my teddy bear Lion when I was a baby, but Lion, he wasn't my favorite. But the bear Jojo, I had a friend named Joe. And so for some reason I called the bear Jojo. Nursery school. People do weird things in nursery school, right? Don't make fun. Finding the product here. This is another special case, and it does involve a pattern, but I'm going to do the same thing I just did on the other slide. So you get y squared, multiply negative 4 times y. I guess I'm going kind of out of a different order than I did last time, but that's okay. So I multiplied y by y. Let me multiply y by 4. We get positive 4y. So I got negative 4y there, positive 4y there, and then negative 4 times 4 is just negative 16. So this case right here, the like terms actually, they end up canceling. So you do get y squared minus 16. You don't have those middle terms. So here's an instance where we're multiplying two binomials, and we end up with a binomial. Another one for you. You can pause it, try it on your own. These two come to 16m squared, and you do need the exponent for m there. You're multiplying m by m and 4 by 4. The middle term will be 28m. I'm going to color this a different color so you can see it. I did 7 times 4m. Next thing I'm going to do, let's use a red here. It'll be negative 7 times 4m, so it'll be a negative 28m. And then the last thing would just be to say that 7 times negative 7 is negative 49. So, in the end, my 28m and my negative 28m cancel out. So you can just write 16m squared minus 49.